Another way that you can be asked questions in relation to working with cylinders is you could get something like this. So they might tell you, for example, the volume of the cylinder is equal to, let's say, 15,840 centimeters cubed. So remember, when we're dealing with volume, we're dealing with centimeters cubed. So imagine they tell you the volume and they tell you that the height, h, is equal to 35 centimeters. 35 centimeters. So again, we're just dealing with one dimension, height. So it's centimeters. And they ask you to find the radius. So the radius is unknown. So they give you the capacity or the volume of the cylinder, which is this. They give you the height, and they ask you to work out the radius. So again, with this kind of question, you need to know the formulas, and the formulas are in your logbook. So what you can do is we need to use a formula that has this radius within it. So if we think about the volume of a cylinder, so the volume is equal to pi r squared by height. Okay, so pi r squared by height. So what we can actually do is we can use this. We can use this formula to figure out the radius or the unknown. So what we do is we just take what we have and we plug it into the formula. So if we think about this, so the volume is 158.40 is equal to pi r squared. We don't know what r is, that's what we want to work out, and we have the height, which is 35 centimeters. So then what we can do is we can work through this and work out what we have. So we want to try and get this radius here on its own, or r squared on its own. Now what we can see is we have pi and we have 35 either side of it, and these are multiplied by. So what we want to do is we want to get rid of those and move them over to this side. Now in order to do that, we can actually divide this side by pi times 35, and if we divide this side by pi times 35, we have to do the same on this side because of the equal sign. So one way to get rid of it is we can divide this side by pi multiplied by 35, and then if we do that on this side, we have to do the same here. This is going to be pi multiplied by 35. And what will happen is this will allow us to, so this 35 will cancel out with this 35, and this pi will cancel out with this pi, and it'll just leave you with r squared. So we can rewrite and say that r squared is equal to 158.40 divided by pi multiplied by 35. So pi times 35. So it looks something like that. So we can multiply this out, and if you use your calculator, what you'll find is that r squared is equal to, so pi times 35 divided by this, it's going to work out at 144.06. So now what we have is we have r squared is equal to this value here. So we've taken this and we've calculated this. Now what we want to do next is we want to get rid of this power or indice here. So the opposite of a power is a square root. So what we actually have to do to get rid of that power and just leave r on its own, we have to get the square of this. If we get the square of this side, we have to do the same on this side as well. So what that will do is by squaring this and squaring this will cancel out with this, and you'll just be left with r radius is equal to the square root of 144.06, which is equal to 12 centimeters. So the radius, so what we can say is that the radius of this, so from here to here, the radius of this cylinder that has a height of 35 and has a volume of that value, its radius is going to be 12 centimeters. So again, this is just another, they can give you two of these, give you like, let's say two of the parameters, volume and height, and then ask you to work out radius. Or they could do it another way. They could give you volume and radius and ask you to work out height. So again, it's just back to manipulating your formula. And if you're working with this kind of question, this is how it would work. Okay, hopefully that makes sense. Thank you.